Hello everyone. Today's lesson is to study the first order ordinary differential equation. Before we go further, let's look what's the application for the first order ordinary differential equation. We can find the application in the motion of the falling body. Even in psychology, we will face the ordinary differential equation on the model of the learning task. Even for the logistic equation, we also have a motion of the particle movement over here, and then Newton's law of cooling. So this is the very popular applications, and also we have the Stephen's law of radiations. Okay, so before we proceed to another things, we need to understand what is the ordinary differential equation. Okay, the differential equation is one that contains differentiable coefficient. For example, if you have dy dt equal to 8x, so we call it this one as a differential equation because we have the terms over here, differentiable term over here. Okay, another example is if you have, let's say, d squared y dx squared plus 2 dy dx equal to x, for example. So this one also we consider as a differential equation. However, for this one, look at here, we have the first order, and then this one we have the second order. Okay, so before we go further on the application or to solve the ordinary differential equation, we need to understand first what is the dependent and independent variable of the term of differential equation. For example, okay, if you have dy dx over here, so this is the terms of the differential equation. So we can what we call pronounce or read this one is dy dx, or you may write with a y primes, or you can have let's say yx over here, so it's all represent the same thing. So in other words, we can read this one as a differentiate y with respect to x, So now we would like to understand which one is a dependent and which one is the independent variable. Okay, so if you are given one ordinary differential equation, for example, if you have del squared x del t squared minus 2 dx dt equal to 5x. So now the problem is you want to identify which one is dependent and independent variable of the equation. So as we can see over here, we can read this function as x depend on t and here depend on t. So when we what we call it spell or pronounce x depend on t, so which one is dependent and which one is independent? Okay, independent. All right. Okay, so it's what we call it very clearly, when you read x depend on t, so t is a dependent variable. Is it correct? No, because x depend on t, so means that your x is a independent variable and then t is your independent variable. Okay, or you may conclude that the one that below over here, we call it as a independent, and then this one as a dependent variable. So if you want to differentiate which one is independent and which one is dependent, so look at the dear equation. The above one we call it as a dependent variable, and then the below one is a independent variable. Okay, so here the independent variable might be vary. So here we have only one variable, and then maybe you will face in 2 variable, 3 variable, and so on. All right. Okay, so let's do some exercise here. If you have, okay, let's say 3x df dx minus 5 dg over dx equal to cos x. Which one is a dependent and which one is an independent? So directly by looking at the above one here, so it's considered as a dependent. So the dependent variable, so you will identify is f and g. And then what is the independent variable? So it's the below one over here. So you will have the x. Alright. So you may go for the example 1.4 and you may answer all the question easily, because you understand that the dependent must be at the above one and then the independent as the below one. As easy as that. Alright, okay. So instead of knowing the dependent and independent variable, so you also need to understand the classifications of the differential equation. So you will have the equation that represent the differential equation, and then you need to identify it by type. So some differential equation might be the ordinary, and then another one is, we call it as a partial differential equation. So to understand about the ordinary or partial, you need to look at their independent variable. Okay, so how to know the PDE or ODE? So it's actually the ODE here. We have only one variable for independent. Okay, and then so for the PDE is more than one independent variable. Okay, so according to this one, this equation is directly is a ordinary differential equation. It's because it's only having one for the independent variable. Okay, let's say if you have, okay, del squared y over del t squared minus del squared y over del x squared equal to 0. So this one you need to look at the independent variable, and then the independent variable we have t and x. So it's obviously is a partial differential equation, or you may check at the notation over here. For the ordinary differential equation, we may use only d. Okay, however, for the partial differential equation, since it's having more than one independent variable, so we use del for that one. So as easy as that if you want to differentiate between ODE and PDE. Okay, now you may classify the differential equation is according by the order. So what is the order? The order is the highest derivative which occur in the term, highest derivative that occurs in the terms. For example, if you have this one, so this one, this is the first order. Okay, then this one is the first order, right? So we call it as a first order differential equation. Okay, so if you have example like for this one, look at this one. Since the by order is the highest derivative, so directly for this term, this is the highest one because we have a second order, so we call it as a second order differential equation. All right, okay, so by knowing the order, you need to check the highest derivative. So if that terms that having highest, then you need to consider that terms as the order of the equation. For example, if you have d cube y over dx cube plus dy over dx, even power of 7 equal to 11 over here. So as we state, the order should be the highest derivative. You need to check the terms over here. Alright, exclude this one. Okay, so this one is the first derivative. This one is the third derivative. So means that for this term or this expression, you have the third order. Alright, let's say if you have another terms over here, so you will have d4y over dx4. So means that if you have this one, so this is the fourth order. As long as it's the highest one, so it can contribute to the order of that differential equation. Okay, so now it's by degree. So what is the degree? The degree of the differential equation. Okay, let's say I write here by degree. So degree means that the differential equation in the highest power of the highest order derivative. So you need to check the highest derivative first. The highest derivative means that you need to check which terms that you consider as a highest order, and then you need to find its power over here. So its power over here is, we call it as a degree. For example, for this one, for this equation, I give more clear equation. Let's say if you have d squared y dx squared plus dy dx plus d cube y, okay, over dx cube over here, okay, equal to x, for example. So which terms contribute to the highest order? So this is the highest order, so means that the order of this equation is 3. And then what is the degree of this equation? Look at this term that you choose for the order, and then look at the power of the whole thing, its power of 1. So means that this expression is a third order and the degree first. Okay, if you have d squared y over dx squared plus dy dx, okay, so here is power of 3 and then equal to x. So you need to check the order first before you go to degree, because the degree is determined by the terms that you are considered to find the order for this one. Alright, okay, so that from this one, you may check that the terms that contribute to the order is these terms. The order is second order, and then also you need to find the degree from this one is a degree 1. You cannot choose this one due to the order are taken from these terms. So it's easy, right? You just need to understand.